Chapter 2, Dimensional Density and the Emergence of Gravitational Time Dilation. Expanded Introduction. In the Millar Cosmological Model, or MCM, the universe does not begin with empty space and time already waiting to be filled. Instead, space and time themselves are constructed, built tick by tick, event by event, through the appearance and disappearance of quantum particles known in this model as blips. As Psalm 90 verse 2 declares, open quote, "Before the mountains were born, or you brought forth the whole world, from everlasting to everlasting, you are God." Close quote. Each time a blip disappears, it leaves behind a tiny allowance of space and writes a moment of time into what the model calls the memory fabric, a cosmic ledger that records every quantum event across all of reality. This idea shares ground with loop quantum gravity, or LQG, which proposes that space itself is quantized, made up of tiny units called spin networks, Rovelli, 2004. But the MCM takes this further. It adds temporal memory, meaning the universe doesn't just have structure, it has history. Every quantum tick is recorded, making the universe a living record of its own becoming. In this chapter, the model applies this idea to explain gravitational time dilation, one of Einstein's most famous predictions, Einstein 1915, but reimagines it as a memory saturation effect, not just a result of geometric curvature. The role of the singularity. At the heart of this process is the Crissy singularity, a state of perfect stillness and absolute balance, the starting point of all creation. As matter begins to accumulate and the singularity ruptures, it pulls in the surrounding memory fabric, saturating it with quantum events. In the Millar model, gravity is not simply the bending of space, it is the densification of cosmic memory, drawing everything toward regions of higher historical density. Time dilation as memory saturation. From the perspective of an outside observer, time appears to slow down near massive objects, such as stars or black holes. This is exactly what Einstein's field equations predict. But in MCM, this slowing is not a trick of geometry alone. It happens because the universe is writing more memory in those regions. Quantum activity increases, demanding more effort to maintain coherence. As 2 Peter chapter 3, verse 8 beautifully puts it, open quote, "With the Lord a day is like 1,000 years, and 1,000 years are like a day." Close quote. This echoes the experience of relativity, where time seems to move differently depending on your frame of reference. In MCM, this writing load makes processes appear slower to outside observers. Thus, gravitational time dilation is redefined as a memory saturation effect, where the universe works harder, filling its ledger faster in those high-density zones. Consequences of memory density. 1. Event horizon redefined. In traditional relativity, the event horizon is the boundary where light cannot escape. In MCM, it becomes something deeper, a phase coherence boundary. Beyond this, quantum events lose their individual identity and time effectively stops. This idea builds on Hawking's work on black hole information loss, Hawking, 1976. NAS 2. Mass as memory density. Mass is redefined as the density of recorded quantum events. This extends Einstein's famous equation, E equals mc squared, by showing that mass is not just energy, but stored memory. The tighter the memory density, the greater the gravitational pull. Stray. Black hole inaccessibility. In this model, black holes are not just regions where light cannot escape, but zones of complete phase incoherence. They exist beyond our frequency range, making them inaccessible, not just invisible. This builds on the Bekenstein-Hawking entropy equation, Bekenstein 1973, Hawking 1974, but extends it by proposing that the true record of the black hole lies not on its surface alone, but woven into the memory fabric itself. Scientific parallels and reinterpretations. Einstein's field equations reimagined. Einstein's equation is written as G mu plus lambda G mu equal frac 8 par C4 T mu. In traditional physics, G mu nu represents spacetime curvature. T mu nu represents stress energy density. In MCM, T mu nu is recast as memory density. Gravity becomes a resonance gradient, phase tension pulling toward denser records in the memory fabric. Bekenstein-Hawking entropy reinterpreted. The classic equation for black hole entropy is S equals frac Kc3a 4g bar, where minus S represents entropy, K is Boltzmann's constant, C is the speed of light, A is the surface area of the black hole's event horizon, G is the gravitational constant, and h bar is the reduced Planck's constant. In the traditional view, this equation suggests that all information swallowed by a black hole gets encoded on its surface area, not its volume. This principle inspired the holographic theory of the universe, where three-dimensional information could be described by a two-dimensional surface, T. Hooft, 1993, Susskind, 1995. But in the Millar Cosmological Model, this idea is both preserved and expanded. While Bekenstein-Hawking showed that the horizon holds entropy information, MCM proposes that each quantum event, each blip disappearance, writes a permanent entry into the memory fabric itself. The surface isn't where the information ends, it's where it transitions into the cosmic memory archive. So in MCM, entropy isn't just a surface measure, it's a growing record of event-by-event memory writing, a ledger of all that has ever crossed the boundary of coherence. The event horizon, therefore, isn't a wall, it's a gateway, a dimensional phase shift, where the universe's memory system absorbs and preserves every quantum moment forever. Loop quantum gravity, complemented loop quantum gravity, or LQG, is the idea that space itself is made of discrete quantized loops, called spin networks, Ravelli, 2004. These tiny loops define the fabric of space, replacing the idea of a smooth, continuous geometry. The Millar model embraces this structure, but takes it a step further. It proposes that each of these spin network nodes isn't just a geometric unit, but a recorded event in cosmic history. Where LQG describes the architecture of space, MCM describes the story written into that architecture. MCM adds temporal granularity, where each node has a timestamp, directional causality, as each event builds upon the last, historical depth, turning spin networks into a living memory archive. This provides not just structure, but a narrative, a recorded history of space and time. Philosophical implications. This leads us to a powerful realization. Gravity is not just geometry or force, it's memory-seeking coherence. In the Millar Cosmological Model, gravity pulls matter toward denser records of quantum history. The universe is self-organizing, drawing its contents toward the places where its own story is written most deeply. This principle mirrors Ecclesiastes chapter 3, verse 15. Open quote, "Whatever is has already been, and what will be has been before, and God will call the past to account." Close quote. In this view, gravity is not random. It is the call of the past, the universe gathering itself into coherence, recording every moment into the memory fabric. Gravity, time, and space are not background features. They are living processes, unfolding tick by tick, shaping a universe that remembers. In conclusion, the Millar Cosmological Model reinterprets gravity, black hole behavior, and cosmic entropy through the lens of dimensional density and memory saturation. It bridges quantum mechanics with its blip-based construction of reality, general relativity with its geometric effects reimagined as memory gradients, and thermodynamics with entropy redefined as a growing cosmic ledger of recorded events. This model offers testable, falsifiable predictions, paving a path toward experimental validation. Most importantly, it invites us to see the universe not as a lifeless machine, but as a living record, a story still being written, preserved forever in the memory of light.